Okay, we've got a Ferris wheel depicted by this circle with a platform 5 feet above the ground. And what else do we know? That the cart makes a complete revolution every 9 minutes, and that the diameter of the Ferris wheel is 26 meters. So that means the radius is 13. That means this line right here is y equals 5 plus the diameter, or 31. And this line here, the low point, is y equals 5. And this is the midline of what's going to end up becoming a trigonometric function. And if I go to Desmos, there's the wheel, Ferris wheel. Here's the position of the one of the carts when t equals 0. As time progresses, by the time we're halfway through at 4.5, we're up at 31, the top of the Ferris wheel. And by the time we go on another 9 seconds, we're back at the bottom. So, and then it starts repeating all over again. That suggests that we might be able to mirror the behavior with a trigonometric function. And y equals the cosine of x is one that we might consider. We know that the amplitude is going to be 13 because the high point is 13 above the midline and the low point is 13 below the midline. So let's put a 13 here and see what happens. Well, it's starting to repeat too soon. We have to change the period by saying, oh, b, the number in front of the x, is 2 pi over 9. And now we're getting closer. I want to move this with a vertical shift up by the value of the midline. Now we're getting closer. But look, at time 0, we're up at 31. We want to be at 5. So what happens if we put a minus in front? It reflects the graph over the midline. Now that's starting to look like our guy. Okay. And I'm going to change this to look like this. Enable this point right here, and watch what happens as t grows. Okay, we can see this x is the position of the cart on the Ferris wheel. They're both at a height of 21.145. So it looks like, and if I keep going, there they are at 4.5, height of 31. We go back to 9. We're back to where we started. And we can keep going. Okay, so it looks like we want to know, when does this graph hit the line y equals 23, which is this red line? And really, we want to know, when is the graph above that red line? Well, it looks like 2.815 and 6.185 are the times above 23, between those two values. How are we going to find that out? So let's go back to Wyzant, and our expression, our equation for the trig function is negative 13 cosine of 2 pi over 9 times x or t, I'll leave it x, plus 18. That's the midline. And we want to know, what value of x produces a y value of 23, a height of 23. Equals 23. So if I isolate the cosine of 2 pi over 9x, by subtracting 18 and then dividing by negative 13, it must be true that 2 pi over 9 x equals the inverse cosine of negative 5/13. And there's two values in the first revolution around the unit circle where the cosine is negative. There's one in the third quadrant. There's one in the fourth quadrant. So if you find the inverse cosine of negative 5/13, and you'll get a x angle or radian value here, and you'll get a radian value here. I'll leave that to you. But then the times are 9 over 2 pi times the inverse cosine of negative 5/13. And in the first revolution around the unit circle, this will have a value in the second quadrant, and it will have a value in the third quadrant where the cosine is negative. And then you subtract them. Okay. I'll send a graph that has that depicted, but hopefully that gives you the idea.